In today's lesson, we are going to be introduced to the design patterns. To be more specific, we are going to first study the Singleton pattern. If you don't have the code of the last lesson, you can download it from here. Okay, so what are design patterns? A software design pattern is a general reusable solution to solve commonly occurring problems in the context of the software development. So they are a methodology to face computer programming that is mostly universally accepted. When they are used in the right way, they allow us to create a clean and scalable code. We are going to start with the Singleton pattern. The Singleton pattern is one of the many design patterns that exist, and it's also one of the mostly used patterns. So the Singleton pattern is a software design pattern that restricts the instantiation of a class to one single instance. That means that of one class we only can have just only one single instance for the whole project. For example, if you recall, when we created multiple enemies or multiple NPCs, we have multiple instances of that element. In the case of a singleton, it means that we can only have one instance in the whole system. So based on that information, what class in our project could we use as a singleton? Just think about it. And possibly you have thought about the game controller, because the game controller meets the requirements to be a singleton. We will only have just one single instance of the game controller. Our game controller will act as the main manager to control the main states of our game. And since it's a critical part of the system, all the other systems are expecting for the game controller to exist. So the game controller is the perfect candidate to be a singleton. So the steps we are going to do to convert the code to a singleton: first of all, we are going to copy this code. That is one of the possible ways to create a singleton. Okay, so first of all, copy this code into your project. In the game controller, at the beginning, you can add this code, and we are going to explain what's going on here. Okay, so the game controller, what would happen is that this is an accessor. This is a way to offer to the whole system, to what we saw on the last slide, a way to offer to the whole system a way to interact with the game controller. So thanks to this accessor, anything in the code will know that, okay, I have this way to access to the game controller. What I mean is that you don't have, for example, when we were working and we wanted to make reference to something, usually we created a public member variable, and this public member variable, what we did was in the inspector, we were setting that particular value with something, either a prefab or even in the same scene. In this particular case, we don't need to do that, because thanks to this accessor, we can access from anywhere in the code what the game controller is offering. So let's try to learn by example, and the example that we are going to do is that if you remember, on the class enemy and on the class NPC we have the reference to the player. Okay, so what we are going to do is instead of getting the player just in the start method right here, we are going to get that information by asking for that information to the game controller. Okay, so the game controller is going to keep the information, is keeping the information about the player, and the only thing that we need to do is that right now, instead of looking for the player, we are going to ask to the game controller to give us that information. Okay, so what we can do right now, for example, is let's start with the enemy, remove the player. Okay, and in all the places where the player appears, now we are going to ask to the game controller to give us the player, because the game controller has a reference to the player. So in here what we are going to do is just to replace this for game controller. Now we type instance, that it is the accessor to access to the game controller, and now we can ask to the game controller to give us the information we want, that is my player. By this way we are asking to the singleton through the accessor that the game controller can give us the information about my player. Okay, and we are going to replace all the reference where we were accessing to the private variable member by just accessing to that information that we are asking to the game controller. So go ahead and change all the reference in both enemy and NPC. Okay, so go ahead and complete the task. Okay, if everything works as expected, now if you run in the Unity editor, everything should run as expected. So you get close to the enemy detects the player and starts to shoot the player as soon as it gets into shooting distance, and it keeps following the player until the player is outside its detection range. In that moment the enemy goes back to the initial position. Let's keep moving forward, and now we are going to do another example of the use of the singleton pattern for our game controller. What we are going to do is we are going to create a new method in the game controller that will be called the method alarm enemy nearby. And this method will go through all the existing enemies, and it will detect if the enemy is close to the player in order to report that the player is in danger. Okay, the function, we are going to keep it simple. The function is going to return true or false depending if there is any enemy nearby the player. Okay, and as a parameter we are going to define a float called distance detection. This float value, it will define the distance that this method is going to check if there is an enemy nearby. Okay, so tips, just use the for instruction to go through all the enemies. Use the method vector3 distance to calculate the distance between 2 points. Okay, and just check previous examples that we have already done for the for instruction. Okay, so go ahead and implement this function. Okay, and the solution should look similar to this. We have declared a public function that will return a Boolean value. This method has a parameter that is distance detection, that is the value that will define the distance that we are going to check if an enemy is inside this detection distance. And what we have done with the body of this function is we have used the for instruction to go through all the enemies, and in case that the enemies are not null, that is the enemies have not been previously destroyed, we are just getting the distance using the vector3 distance, getting the position of the enemy and the position of the player. With these two values we get the distance between both of them, and if the distance is below the detection distance, okay, we have an enemy inside this detection range, we return true. In the case that we don't find any enemy inside this detection distance, this condition will never be true. So we will exit by this way, so we will return false. The next step we are going to do is to create the UI in order to display that we are nearby an enemy. Okay, so what we are going to do is we are going to add a UI element of the type text that where we will be able to display that there is an enemy nearby the player, so the player is in danger. After creating this text element, okay, we are going to reference it. So we will create in the player script a public member variable of the type text that will reference the previously created UI element of the type text in the Unity editor. After getting the reference, now we can create a new method in the player script that will be called check to display danger. And this method will call the alarm enemy nearby that is offering our GameController Singleton. Okay, so go ahead and implement the instructions I have described. And the implementation should be similar to this. So what we have first created was the text element in our game HUD. Okay, we have created this text element, and we still have to align it with a better anchoring. So this anchor will be our best option when the screen resizes. Okay, so we have created our text element, then we went back to the code to create the reference, okay, display danger info, and we went back to the code and we were setting the display info with the new text field. Okay, back to the code. In the start method, we are initializing this text component to nothing. Okay, And the next thing that we have done is just to implement the method check to display danger. And in the body of this method, what we are doing is just calling what our game controller is offering us, that is the method alarm enemy nearby, and with one parameter, the distance that we are interested to check. If this method returns true, there is an enemy nearby, so okay, let's display a message telling the user, okay, the player is in danger. And if there is not, then just to clear the existing message, okay? And what we have forgot is just to implement that is checking both in the state idle and in the state walk. So if the player is in both state idle and state walk, it will call the method check to display danger, and this method will call the singleton, the alarm enemy nearby, and it will refresh the text component just to display if the player is or not in danger. Okay, if everything is working as expected and we proceed to run the game, okay, let's play it. And now let's get closer, let's clean the log, okay? And if we get closer to one enemy and the enemy, okay, the message is there. The problem is that it's in white, but the message is there. And if we get away of the enemy, the message has disappeared. Just for the sake of being able to watch it better, just take it and put the color to black so it's way more visible. Do the same test and you should get a more visible message, okay? Okay, to finish with this first part, we are going to do an exercise about implementing a method in the game controller that will be called alarm NPC nearby. And what this alarm NPC nearby is going to do, this function is going to tell us if there is any NPC nearby the player. So almost exactly the same that we have already done for the enemy. We are going to do it, but to be able to detect if there is NPCs nearby the player. Okay, so I recommend you to start just by creating a new text field in the game UI, where you will you will use to place information that there is an NPC nearby, and just use what you have learned about alarm enemy nearby and apply it for the NPC case. So go ahead and do it. Okay, and the result should look similar to this. So we have started by adding a new text field to the game hack, where that we will use to display that there is an NPC nearby. Okay. The next thing that we have done is just to go to the player script and create the reference that will reference the previously created text element. Okay. After that, we save it and we set the instance of the player to, no, we have forgot, so we are going to set it right now. Okay, now it's set. Now on the start method we are going to initialize this text field to empty. Okay, and we have just copy paste the whole check to display danger into check to display NPC. Okay, and right now we are calling the Singleton game controller, but we are controlling the new method, the new function alarm NPC nearby. Okay, if this function returns true, okay, there is a friendly NPC nearby, and if it's false, well, the information will be cleared. And finally, what we have done is on the game controller, we have just implemented the new method alarm NPC nearby, just exactly in the same way that we have done for the alarm enemy nearby. We go through all the NPCs, we get the distance from each NPC to the player, and if the distance is inside the detection distance, we will return true. If not, we will return false. Okay, if everything has gone as expected and we proceed to run the application, now we are going to get closer to an NPC just to check that this new message is appearing. Okay, so a friendly NPC has appeared. If we move away, the message disappears. Okay, as a final test, let's display both messages at the same time. Enemy nearby, NPC nearby. Okay, we are good. If we get away, okay, everything is cleared. Okay, so we are good. In the next step of the Singleton pattern lesson, we are going to be introduced to the language controller. So we are going to keep exploring the Singleton patterns with two more examples. And the first example will be this language controller. That it's a singleton that will handle multiple languages. When you develop professionally games or software, you will need a system that will be able to handle multiple languages. So you would have this singleton controller and different parts of the system that need to display some kind of message will ask the language controller to get the right text for the right language. So the first thing that we are going to do is just to create a new script called language controller in the folder controllers. So let's go to our code. Okay, and we can create a new script called language controller. Okay, and on this script we are going to add an accessor, so we can access to the language controller as a singleton. We replace the reference to the other code, and the next step that we are going to do, we are going to go back to the editor, and in the scene we are going to create a new empty object that we will rename as language controller. Okay, so create an empty game object, call it language controller, and add it this script. Okay, language controller. Okay, the next step that we are going to do, we are going to create a new public variable member that will make reference to the file that will contain all the texts that are going to be used in the Unity project. Okay, so just copy paste this variable member, go to the code, Okay, and this variable member is of the type asset. This would mean that it's a reference to a file. So the next thing that we are going to do is we will create a file that will contain all the necessary information on all the language in order for the language controller system to work. So, but first of all, we are going to be introduced to what is called the XML format, because we are going to use this format to define that file, the file that will define all the languages. The official definition of the XML is like this. XML is a markup language that defines a set of rules for encoding documents in a format that is both human readable and machine readable. Okay, the XML format was born in order to ease the process of introducing data for the humans, for the machines to understand, but trying to get a compromise between both. In short, for our case, it will allow the designers to create files of data that are going to be used in the game. The XML file it's more closer than to a more natural language, or at least is easier to understand for designers. Okay, so the next thing that we are going to do, we are going to see some examples of games where I have used XML definition, both to create the language files and also to define the game levels. For example, let's start by order with Zombie Baseball. Zombie Baseball 3D, in this case, this is a game that I made both for VR and also there is a desktop and a mobile version. Okay, and I am using the XML file to define the type of the zombies that are going to attack you, and also the life of that zombies and the frequency that these zombies are appearing. And how I do that? Let's check the XML file where I am able to customize that values. Okay, so if we open this file, okay, this is the file I am using right now in that game, and this is the file I use in order to set to customize the game, to set how it's going to behave at least some part of the game. For example, I start with a header, and in this header I set some values related to some global variables or global properties, like could be the damage of the base bat. There are different types of bats, and each bat has different properties. For example, the normal bat has a damage value of 50, the ice bat has a damage of lower of 25, the bat fire has a higher value, and just a collection of different values of global character in order to customize some global properties of the game. Related to the levels, the game has multiple levels. In each level there are multiple zombies that are going to attack you, and the way I use the XML format to define the waves is like this. First of all, let's open a notepad and we are going to do it together. So as I was saying, the way I define a wave of zombies, I would start with what is the first tag, the initial tag, that would be wave. Okay, and to define that the ending tag, it would be the same name but with this additional symbol. So the code that we are programming will identify what is inside here as a unique token. Okay, and we will be able to parse that content in the way we want. Okay, so we are just starting to define the wave, and you can define some general properties of the wave. For example, in this case, I define that the identification of this wave is 0. So we have an identification 0. The timeout property is the time that the level takes to warm up before throwing at you all the zombies. Okay, so we wait some seconds. The level, it's just the visual representation of the level, and the upgrade are the collection of points you get by completing successfully the wave. So for this wave we can define a collection of parameters related to that specific wave. Okay, so next step, we are going to define what zombies are going to attack us. Okay, to define a new entry, we can start with the name that we want to use, zombie, and as I said, we can make the ending tag just to define that everything that is here, our software code is going to parse it as a single token. Okay, but in this particular case, instead of using the convention of starting with this tag and ending with this other tag, we are going just to use a single line. Okay, to use a single line for our code to consider this as a single line, we have to end this code like this. Okay, and here we are going to specify the parameters that define the properties of that specific zombie. For example, just copy paste the whole thing. Okay, and what we will do here is, okay, first of all, the zombie has an index, a position on the array. The zombie has a life. Okay, this life value, when you are progressing in the game, as you can see, the life value is increasing and increasing and increasing, making it more difficult to kill them. Okay, the speed value means the speed that the zombie is going to move towards you. There will be fast zombies and slower zombies. Okay, the score is the score you get by killing that zombie, and the upgrade is well, it's something that is no longer used, but remained there because I forgot to delete it. Okay, so by this way, for this wave of zombies, for the wave of this level, we have created our first zombie. Okay, our first zombie of the type 0. Okay, with this life, with this speed, with the score we get for killing it, and well, we would repeat the same process, just using different zombies. So, for example, the zombie 2, the zombie 1, the zombie 2, the zombie 3, and setting different life values for each different zombie, setting different speeds, and just like this, we would create our level with all the zombie enemies we want to use in this specific level with its own properties. This information, it's easy to understand for the designers to use it to customize the game the way they want, in order for them to get the expected behavior. So let's check another example of an XML applied to game. So this is a tower defense game. That the goal of this tower defense game is to defend a planet from invading armies, and you have your own spaceships that are patrolling around your planet, defending the attacking waves. Okay, so let's check how each attacking wave is defined. In this case, for each attacking wave, I have defined an XML file. Let's check just one. And in this particular case, for each wave, I first define the tag wave. Okay, and define inside the tag wave, I define subwaves. Okay, these subwaves will appear with a delay of 1 second, of 6 seconds, and the final wave will appear after a delay of 12 seconds. And for each wave, first wave, we create 3 shapes, 1, 2, 3. Okay, and there is a collection of parameters which we use to customize each spaceship. Okay, the angle that it's going to appear in the game. Okay, so the first one appears in the angle of 270 degrees, but this is inversed. So instead of being 90 degrees, it's 270. The second wave appears just by here, that it's the angle of 0. Okay, and the third and final wave appear in this angle, that it belongs to the angle of 180, that it's the exact opposite of 0 degrees. Okay, so this is another example of the use of an XML to be able to define and customize how the game is going to behave. Now that we have seen an introduction to what is an XML file, we are going to use an XML file in order to create the file that will use our language controller to provide different translations for the text that the game needs. Okay, so let's check an example. Again, we're going to check a game I made. It's the Zombie Baseball 3D, and let's check what we did for this game. And this is the file that I am currently using for the Zombie Baseball 3D. Okay, in particular for language, for example, for this screen. If you can see the text that I am using in this screen, at least I have 2 translations, one for English and another for Spanish. Okay, and the way I define the XML file is like this. Okay, I first start with the first initial tag, I conclude with the ending tag, and I create multiple entries for each of the texts I need for the game. So let's do it as an example. For example, each entry is composed like this. We will start by defining the tag text. Okay, and here we define as a parameter an unique identifier. This unique identifier is what you are going to use in the code in order to retrieve the right text, and it will be the language controller to decide, once he has this identifier, he will provide us with the right text, with the right translation. For example, let's make this one of here, the single player game. Okay, so we will start by typing the unique identifier. That will be, I have used a screen, choose single player. Okay, so when we are coding and we need to get the text related to that, to showing single player game, we are going to use this unique identification in order to find what we need, the information we need. Okay, we will finish with the ending tag. Okay, and now it's time for the different languages. Usually, as you know, there are conventions about using two letters in order to identify different languages. In this case, we can use these 2 ones that they represent English and Spanish. Okay, and each of these 1 entries, we will type the text related to that language. So here we have single player game, and here we will have the exact same definition, but in another language, in this case Spanish. Okay, So here we have the English translation and the Spanish translation. So our code, what we'll do is, okay, I want to use the text related to the single player game. Okay, I look for this identification, and the language controller will get us, if we are in English, we are getting this text, and if we are in Spanish, we are getting this other text. More languages, I don't know, Italian. You would write here the translation on Italian, the translation on any other language you can think of. Okay, so here you have a flexible enough system in order to define as many languages as you want. Okay, and you would do this identification for all the different text that your game is going to have. Okay, so you will create, okay, now identification for multiplayer. Okay, so multiplayer game here, and multiplayer in Spanish here. Okay, and you would go on and on and on for all the text in your game. Okay, so the exercise that you are going to do now is that you are going to create this file of languages for our project, and you are going to create at least 3 entries inside this language file. Okay, 1 entry for the main menu, 1 entry for the win screen, and 1 entry for the lose screen. Okay, let's go back to the code of the project, and the text would be displayed. Okay, the text will be displayed in the main menu. Okay, it will be displayed right here, my awesome game. Also in the win screen, you also have to create a new text entry to be displayed right here, and finally another entry for the lose screen. You would have to create another entry to be displayed right here. Okay, so let's go back to the exercise. So the steps that you are going to do is you are going to create a file named gametext.xml. You are going to create the first entry tags, and you are going to create 3 entries. Okay, again, 1 entry for the main menu screen, another for the win screen, and another for the lose screen. You have to think about the text you want to show in each one of these screens. Related to the additional language, well, if you have another additional language, great. If not, just invent yourself some other text. I don't know, Google Translate is good enough to get different text, so at least you get an idea. Okay, and if you want to check that the XML that you have typed is right, you have this tool. Okay, so with this tool you can verify if the XML that you have just typed has the right syntax. Okay, so you would type right here the XML, and you would press check XML, and if there are errors, it will tell you if there are errors. For example, let's introduce an error just to remove something right here, and press check, and it contains an error. Okay, error on line 3. Okay, and column 1. Okay, there is an error, so we can correct the error, check again, no errors found. Okay, so go ahead and do this file with 3 entries for each screen. Okay, so go ahead and do it. Okay, and the file should look similar to this. Okay, so we have started by starting tag and ending tag. Okay, and we have created 3 entries. Okay, 1, 2, and 3. Okay, we have defined different identifiers to be able to use them in the code, and we have created the 2 translations, the English translation and the Spanish translation for each one of the cases. Okay, so save this file into the project, assets, game, resources, and we are going to create a new folder here that we will call text, and we are going to save this file without format. Okay, so we are going to call it game text XML. Okay, Notepad++ identifies the extension of the file, and well, it highlights the file and provides some interesting utilities, but only if you are using Notepad++. Okay, and finally check that this file is okay. So go to the XML validator and paste the whole thing and check that you don't have any errors. Okay, so we are good. So now, before going back to the code to implement the necessary functionality to load that file, what we need to do is just to reference the previously created public variable member game text with the file we have just created. So let's do that. Let's go to our language controller. Okay, we have here our game text, and we are going to take the file and we are going to drag and drop it on the public variable member game text to make reference to that file. Okay, so now going back to the code. So this part is going to be guided because we want to focus to understand the singleton, not exactly how the language controller internally works. What is important in this lesson is to understand that the singleton pattern behaves in a specific way. Okay, so now what we are going to do is just to implement the 2 functions. The first would be a method called load game text that will load the previous XML file into memory, and we will create the function get text that will get the translated text by its ID. So let's back to the code, and the first function that we are going to implement is going to be load game text. First of all, you are going to copy these 2 variable members. One is a public variable member that it will contain the language code. In this case, it is selected English. Okay, and the second one is a list. It's a hash table. A hash table is a kind of list that you can use to store a collection of data. Okay, as I said, you don't have to specifically worry about how is this implemented, because the goal of the lesson is to understand that a singleton is just a single instance that you can access from anywhere in the code that offers you some functionality. So this is we are going to go fast in this part. Okay, so let's copy paste the load game text, and what this method would do is just to load our XML file. Okay, let's import the necessary libraries to load the XML file. As a short explanation of what this method is going to do, first of all, it checks that this hash table has not been already filled. Okay, if it hasn't been filled yet, then it's the first time we try to load the text, and we proceed to declare a type, a variable of the type XML document. This variable will allow us to load the XML file we have created before, and we will be able to use this variable to get the information we need from that XML file. Okay, the first operation we are doing with this variable is to load the data from the file. Okay, so to access the data from the file, the text asset has the property text, okay, that it returns the text of the file. So we load that information, and using XML get elements by tag name, we are getting a list. Well, we are getting this type, a XML node list, that it's a list of the elements we have created. Okay, if you go to here, we would get all these elements inside the XML node list. So the next thing that we need to do is to go for each one of these elements and parse it. Okay, so we use for each, that it's another way to go through a collection, and using this syntax we can go through each element of the previously created list. Okay, and each element of this previously created list is of the type XML node. So we get that information, and from that information we are able to get the ID. So by ID I mean this one. Okay, and we create a new entry inside our hash table. Okay, to add a new entry into the hash table, we used the method add, and the method add has two parameters. Has the parameter of the key, that it's the identification that we are going to use to find the text that we are looking for, and an object. In this case, it's an object that you are going to import right now from here. Okay, so in this link you should download this file, and you are going to place this file into your project, into a new folder called utils. So create a new folder, call it utils, and leave there this file. Okay, so go back to the Unity editor so it recognizes the new file. Okay, we have the folder here. It has compiled the script. Okay, and what is text entry? Basically, text entry just contains all the necessary structure to keep the information related to an entry of the text file. Okay, so we will keep the ID here, the ID, and we will keep another hash table that will contain each one of the translations. Okay, so going back to the load game text, we don't have any compiler errors, and we are adding all the necessary text into our collection of text. Okay, the next thing that we are going to do, we are going to just to copy the function text, and we can already remove start and update, because in this case we are not going to need it. And let's review what we are doing here. What we are doing here is just to it's a function that we call specifying one parameter, that it's the ID we are looking for. It means that we are going to look by this ID. Okay, and what it returns is it gets the text for the ID inside the hash table. And if we go to the definition of get text inside the text entry, in this method we are getting the translation for the specified language, and the specified language is code language, that it's English. So now that we have everything in place, let's do together just a case of the use of the language controller to get the text we want, and then you will do it for the other cases. Okay, so the case that we are going to do is for the main menu screen. So let's go to our project, and we have to locate the activation screen menu main in our GameController script. So we go to the GameController, and the moment we are activating the main menu screen, okay, right here, we are interested in that specific moment. So now what we are going to do, we are interested in that specific moment for this screen, for a screen main menu screen. We're interested to access to the text field where the title is being shown. Okay, so we're interested to get this text component in order to be able to change it the way we want, with the language, with the translation we want. Okay, so just do the exercise right now to look away to access to a child inside a game object. You can get that information if you search by this pattern. Okay, and from that transform that you are getting from this child, you are going to get the text component. Okay, so do it. And the solution should look similar to this. So what we have done is that transform has a method that is called find. This method has one parameter that it's a string, and this is a string of the name of the child that this transform wants to look if it has this child. Okay, so we are on this screen at this level, and we are asking, okay, this transform, this game object has in its a child with the name title, and that's what we are doing here. We are asking, okay, do we have a child with the name title? And yes, we do. We have this child with the name title. Okay, so we would be getting the transform from this function, and from this transform we can get the component attached to title, the component text, that in this case is not text mesh, it's not a text component, but it's text mesh pro. And we are getting the component text mesh pro from the child title. Okay, and now from that component we can set a new, and we can access to the property text that will allow us to set a new text. Okay, we can do the test right now, and if we press play, we are getting a new text in the title. So now that we have the reference to the right text, we can use our language controller to get the text we want to use for the title of the main menu screen. So the way to access the language controller is language controller instance get text, and you have to specify the ID that you have used for in the XML file. Okay, in my particular case, the ID that I would be using, it would be this one. In your case, if you have used another different, it would be yours. Okay, so do it. And the solution should look similar to this. We are accessing the singleton through the accessor, and we are getting the functionality of getText. GetText needed the ID of the text we are looking for, and we are going to get the text for the code language for English. So we would be getting the welcome to my game text. Okay, so now it's time to save and test it. Save the code, save the scene, and play it, and welcome to my game. Okay, this is the text that I have defined in the language file. Okay, so we are good. So what you are going to do right now is that for the language you have defined for your file of text, okay, you are going to use the alternative. In my case is Spanish. Okay, so what I am going to do is just to change the language code from English to Spanish, but I need to do it in the inspector. Okay, in the inspector I am going to set as Spanish, and I would be getting the title in Spanish right here. Okay, here is the title in Spanish. Okay, so we are good. Our language system to get different translations is working. Okay, so now what you are going to do, you are going to do the cases for the win screen and the lose screen. Okay, so what you are going to do is for the win screen, and you are going to look for the child, in this case is text. Okay, and you are going to get the reference to that text in the game controller. Okay, in the activation of the win screen. In that particular moment you are going to do exactly the same as you are doing right here for the main menu screen. Okay, so you are accessing the transform, finding the child. For the child you are getting the text component, the Text Mesh Pro UI component, and you will be using the singleton of language controller to get the right text. Okay, so go ahead and do it both for win screen and for lose screen. Okay, and the final code should look something similar to this. Okay, for the right moment that we are changing the state to the states win and lose, the activation screen win game and the activation screen game lose, in that particular moment we are looking for the child of that particular screen, in this case screen win game. We are looking for the child called text, getting the Text Mesh Pro UI, and getting the property text in order to set the text that we want to use, getting that text by the ID using the singleton controller. And we are doing exactly the same for the lose screen. Okay, since we are still on Spanish, let's it would be more clear that we are using the language controller for both lose and win screen. Okay, so let's go into for the win screen right now. Let's go into kill all the enemies, and okay, we are getting the congratulations screen in Spanish, and what we can do right now is test the lose screen. Okay, I think that okay, we are reloading the game, and right now we are going to die to get the lose screen text, and just to check that everything is in order. Okay, 2 enemies are killing us. Okay, so we are getting the right text in Spanish, so our system is fully working. So the last step we are going to do to conclude the language controller singleton part is that we are going to create a button in the main menu screen that will allow us to change the language in runtime from English to Spanish and from Spanish to English. Okay, so the steps that you are going to do are these ones. Okay, first you will create the button on the screen. Next you will create a switch language public method in the GameController that will be called when this button is pressed. Okay, in this method switch language we are going to change the language code that we are currently using, okay, for the language controller. If we are using Spanish, we will change to English. If we are using English, we will change back to Spanish. Okay, just to change, since the code language it's a public member variable, it's accessible from the outside. Okay, so you can directly assign the code like this for English and for Spanish. Okay, and once you have switched the code language, you need to refresh the text in the text of the main menu screen. Okay, so go ahead and do it. Okay, and the code should look similar to this. We have created a new button right here. Okay, and for this button we are going to add a new on-click event right here, and we are going to make that when the user press on that button, we are going to call on the game controller the method switch language. On the method switch language, what we have done is we use the conditional if to check, okay, if the language is using this code, then switch to English. If not, then switch to Spanish. That will allow us to switch back and forth between the two currently defined languages. Okay. The next thing that we have done is just to update the text of the inside the button. Okay, I had forgot this one. You can specify childs, look for childs also with a path. And I am setting in that button just what language code the system is currently using. Okay, and after that we are refreshing the for the screen main menu the title. Okay, so if everything goes as expected and we proceed to play, okay, we got a compiler error. Okay, let's see what's the thing, and the path here to the text inside the button is not right. Okay, let's go back to the project. Let's try it again. Okay, we get that right now we are using Spanish, and if we press on this button, we have switched it back to English. We can switch back and forth between these two languages. Okay, so that would be for the language controller Singleton. So let's move forward, and now we are going to see another example of Singleton pattern, that is the sounds controller. Okay, so another class that you could have only one instance is a class that is going to handle the management of the sounds. Okay, so there will be two parts in the implementation of this particular class. First of all, we are going to implement what are the background sounds, that is the main menu music, the in-game music, the victory music, and the lose music. And the second part would be the implementation of the FX sounds, that is sounds like the shot or the scream that the enemy does when he dies, or the same scream for the NPC when he dies. Okay, so we are going to create our sounds controller, and many elements of our system are going to use it in order to perform different types of sounds. So let's go back to the code, and the first thing that we are going to do is to create the script called sounds controller in the folder controllers. So go to the folder controllers, create a new script, and call it sounds controller. In the scene, you are going to create a new empty game object that you will also call sounds controller, and you would attach the sounds controller to this new game object. Now select this component, and we are going to add two channels to play the sound. The sound channels to play the sounds are called audio source. Okay, so look for audio source, add 2. Okay, so we add 1 and we add 2. We are interested to have two channels, one for the background music and another for the FX sounds. Okay, short summary of what's in here. The audio clip property is just the audio clip this channel of sound is playing, and some properties like as mute. Well, there are multiple properties in order to fully customize the way that you want to play this particular sound. I let you to investigate these properties in the case that you want to play around and experiment with them. So let's go to the code, and the first thing that we are going to do, we are going to create the accessor for this new Singleton. Okay, so just you can copy paste any previous accessor and fully change the name to the new class. Okay, and you would get your accessor, so you are able to access from anywhere from the code to what the sounds controller is offering. Next, what we are going to do is we are going to get the reference to these two previous audio sources that we have created in order to be able to control them, to use them to play sounds. Okay, so the first thing that we are going to do is that we are going to create two private members. Okay, you can just copy paste these two. Okay, and these two private members are of the type audio source, that is the same type that we are using for the component, for the channel. So we are interested to get the references to these two audio source. Okay, and in order to initialize them in the start method, we are going to use the property getComponents finished with s that will return an array of the components that he finds in this same game object that is in the sounds controller. Okay, it gets these components and it returns an array of the audio source components. Okay, and we just assigned to the two members of this array, one for the channel of the background sounds and one for the channel of the audio effects. So next we are going to create an array where we will put all the sounds we want to use in the game. So we are going to create a public member variable that will keep all the sounds. So just you can copy paste this, and the type audio clip is the type that allow us to use soundtracks. Okay. For the soundtracks we are going to use this collection of sounds that are from previous games that I have made, so you are free to use it any way you want. Okay, so just download them from this link, and we are going to place all these sounds in our project. Okay, let's create a new folder in the resources that we will call sounds, and we will place all the sounds here. If we go to the Unity project, the editor should recognize all these tracks, and now you can select them and even play them. If you select them, the properties here would appear. Okay, and you have the option here to play this sound. Okay, this is the congratulations sounds, this is the main menu sounds, and some of the effects, for example the effects of the shoot, and the effects, for example, of the enemy dead. Okay, we have the sounds that we want to use in our game, and we only need to fill the previously created array in order to be able to then play them. So save the sounds controller if you don't have already saved it, and go back to the Unity editor, and now we have the list of the array available in order to fill it with the sounds we are using. So we are using 7 sounds, so let's set to 7, and let's fill it. Okay, you can fill it any way you want, the order is not important at this stage. Just place all the clips there. Okay, so we have filled the array of sounds. So right now the sounds controller has access to all the sounds that he wants to play, and we have also the references to the 2 channels that we want to use to play the previously created sounds. So now that we have both the references to the sound channels and the sound clips that we want to play, let's going to use them. And what we are going to do right now is we are going to implement what would be the functionality to play the background sounds. Okay, since the goal of this lesson is just to understand the concept of singleton pattern, we are going to copy paste this code in order to be able to use it. Okay. Okay, so what this code is going to do, play sound clip background has 3 different parameters. The parameter audio clip, that it's the audio clip that we want to play. The parameter boolean loop, that is if we want this sound to play in a loop mode or just once. And the parameter of the volume. The volume is between 0 to 1, and well, it's the volume. And what we are doing here is we are assigning to this channel the audio clip that we want to use. We are setting the property loop with a property loop, the property volume with the value volume, and finally the only thing that we are doing here is the audio source has the method play that allows simply to play that sound. Okay, so that's for it. And for the stop sound background, what this function does is just to reset the audio clip and stop the sound. Okay, so next what we are going to do, still in the sounds controller script, we need to create a public function that this singleton will offer to any part of the system that wants to play a sound. So what we are going to do as an exercise is that you are going to create a public method called play sound background, and this method will have 3 parameters. The first parameter is a string called audio name, and it contains the name of the audio you want to play. What is the name of the audio you want to play? The name of the audio you want to play is just each one of these. Each one of these, if you get the name of each one of these audios, you are going to get exactly this name. So what we are going to do is to go through all the elements of this array looking for the name of the audio we want to play. Once we found the audio we want to play, we will be able to retrieve from that array the audio clip in order to use it to the previously created method in order to play this particular audio clip. So the exercise would be to go through all the elements of this sound array, searching for the audio by its name. Okay, just remember that you can get the name of the audio clip just by using the property name. Once you have found the right audio clip, you can call the private method that we just created, the play sound clip background, with the right parameters. So go ahead and do it. And the result should look similar to this. Okay, so we have created the public method with the 3 parameters we have talked about, and here is the name of the audio that we want to play, and we have gone through all the elements of the array of sounds looking for the name of the sound that we want to play. Okay, once we have found the name of the sound we want to play, we just get the audio clip and use the previously created method in order to retrieve the audio clip and play it. In order to help us to look for the audio that we want to play by name, that what we are going to do is just to create a collection of constants that we will be able to use just to make reference to the name of the sound we are looking for. So just copy paste these constants on the sounds controller file, preferably in the top part of the class, and these are the constants that we are going to use in other parts of the code in order to play the sound that we want. So now it's the time to use the singleton to play background music in our game. We are going to start just by playing 3 background melodies. That would be the main menu melody, the victory melody, and the loose melody. So find out where you should play these melodies, and just call the singleton to play that melody. So go ahead and do it. Okay, and the result should look similar to this. We are using our method change state just to detect the exact moment that we are changing of state, and in that particular moment, when we are changing, for example, to main menu state, in that particular moment we are accessing the Singleton sounds controller and using what it is offering to us, the play sound background, and we are specifying, okay, let's use the melody main menu sound. Okay, next we are specifying that to play this in loop mode and with the volume to the top, to 1. And we are doing something similar for the case win and lose. In the right moment that the game controller is changing the state to win, we are playing the melody win audio clip. This time we don't want it in loop mode, and we want it to the top volume, to 1. And we are doing exactly the same when we transition to the loose state. We are just playing the melody loose. So if everything is in order and we proceed to play the game, the first sound will be the main melody menu. Okay, we are hearing the main melody menu, right? And we are going for example, the okay. So we have noticed that we are still playing the main melody menu. So we need to do something else. So think for a second what we need to do. Okay, and you should have come to the same conclusion as I do, is that the moment that we transition from main menu to load game, we are going to stop all the sounds, all the background sounds from playing. Now we can go back to our Unity project, proceed to play, and now when we press play, the sound on the background should stop. Okay, that's right, the sound of on the background has stopped, and let's go to play the win melody. Okay, let's kill all the enemies.
Congratulations!
And we are playing the main melody sound. Okay, it would happen the same for the loose sound. So if we lose, okay, let's get killed fast by 3 enemies at the same time, and we are getting the melody of losing. Okay, so the background sounds are working fine. So the exercise that you are going to do next is to implement the effect sounds. Do you remember that we created 2 channels, 2 audio sources, one for the background noises and one for the effect sounds? So now you are going to implement in the sounds controller, you are going to implement 3 methods. First of all, the private method play sound clip FX, that it's the exact equivalent to the play sound background that received the audio clip that needed to play. Okay, but this time you are going to use the other audio source, because we are going to use the other channel in order to play the sound. Why is that? Because usually in a game you have a background sound, and over this background sound, in-game sound, you are going to play some FX sounds. Okay, so you are going to implement this private method. Then you are going to implement also the stop sound effects, that it's also the equivalent to the one that we did before for the background music. And you are going to create the public method that the Singleton is going to offer to the other parts of the system in order to play the FX sounds. Finally, you will create the constants for all the FX sounds, and finally you are going to use them in the project. Just find out where you need to use these FX sounds and use them. Okay, so go ahead and do it. Okay, and the result should look similar to this. So we have just copy paste what we did for the channel about the background music, but in this case we are going to use another channel, the one that we are using for the FX. So we created a private method that was the final responsible just to set the audio clip and play it in the FX channel. We created the stop FX sound in order to be able to stop all the sound of this channel. And finally, we created the public method that the source controller Singleton is offering to any part of the code in order to play the FX sound. Then we created the constants related to that FX sounds, and we proceeded to use them. Okay, so the first one that I have detected is the one that when the player shoots. Okay, well, in this exact moment we call the Singleton and we call the play sound FX with the name of the FX sound. Okay, and here we are playing a shot. The next one I detected was for the enemy to die. In the exact moment that the enemy changes the state to the state die, in that exact moment we are playing this FX sound of the enemy dead. And we did exactly the same for the NPC. When the NPC dies, also he plays his dead FX sound. If everything is in order and we proceed to play, we should be able to hear the shot. Okay, one shot, two shots, and let's kill an enemy. Okay, we haven't heard the audio of the enemy killed, so let's check what could be going on. So we are not entering this state, the state die. So if we check where it's called, Okay, the conditions of checking the life to 0 are right. We are checking the life right, but it seems that the state is not changing to the state died, and the reason is because of this. When we are decreasing the life of the enemy, when the life is equals or below 0, we are just destroying the enemy. We are not changing the state of the enemy to the state died. So let's going to do that. Change the state to the state died. And we are going to do exactly the same for the NPC, because I fear that the NPC has the same problem. Exactly, has the same problem. So now we are changing to the state die, and the state die will reproduce the FX sound, and in the update method it's called when we enter to the state die that this object is destroyed. The same for the case of the enemy. It will enter the state died, and also it will be destroyed right here. Okay, so save it, go back to the Unity editor, and let's go into play it. Okay, so let's, and the final edit. Okay, so we have heard the effects of the enemy dying. Let's go for the effects of the NPC dying. Okay, so let's go for it. I think this is the last shot. Another one. Okay, and this is the effects of the NPC dying. Okay, the three effect sounds that we have used, the shot, the effects of the enemy dying, and the effects of the NPC dying are right. Everything is in order. Okay, as a final exercise, what we can do right now is, okay, just find out, we have still one background melody to use. That would be the in-game melody. Just use it. Okay, so find out in the code where to use it, and play the in-game background sound. Okay, so go ahead and do it. Okay, and the result should look similar to this. We are just playing the melody sound when we transition to the state to game running. In this particular moment, we are playing the background in-game background melody in loop mode. And when we transition to win or lose, we are stopping the sound before playing the win melody and the lose melody. So let's do the final test. Okay, we have here the in-game melody. Okay, so we did it. All the sounds are in order. So to conclude this sound singleton introduction, I propose you to do the next exercise. I propose you to create another sound channel, and this new sound channel is going to be used by the NPCs to say things to the player. If you remember, when the NPC was in talking range to talk to the player, what we were doing was to display a debug log message. What I propose you to do is, in this case, just to play a voice sound. Okay, so create a new sound channel that would be used for the NPCs to play voice tracks. And you can generate audio tracks using this generator, this online generator. You can use it to create some tracks. Okay, so if you just create some tracks like this, and
hello world,
you can type anything what you want.
How are you?
Okay, so feel free to use it to create some clips and to implement the solution in order for the NPCs to say things to the player when they are in talking range. Okay, this is an optional exercise. You are free to do it. I recommend you to do it. And with this, we conclude the part of the sounds controller singleton. So let's keep moving forward with the singleton patterns, and the next one that we are going to see is the level controller. So in our learning process, we are going to keep organizing the project in order to grow more clean and organized. Okay, so the next step to grow the project in a better way is to create a system to load different levels. Okay, so we are going to create a script called level controller that will manage all the elements of the game. So let's go to the code, and in the folder controllers we are going to create the new script level controller. Okay, and in this script we are going to add the accessor. Okay, so just copy paste an existing accessor, and we are going to place the accessor right on the top, replacing the name of the class here. Okay, so we have our accessor. The next step that we are going to do, we are going back to the Unity editor. Okay, and here we are going to just make sure that the player is not inside the level. Okay, that's fine. And we are going to convert the level into a prefab. Okay, so we are going to the folder assets game resources prefabs, and here we are going to create a folder called levels. Okay, and inside this folder we are going to drag and drop the current level to convert it as a prefab. Okay, next we can remove the level from the scene because we are going to instantiate that level. And now on the GameController class we are going to create an array of levels, because our idea is to be able to change of levels as we progress forward into the game. Okay, so we are going to create this array. Let's go to the GameController, and we can create the array just right here, and we are going back to the editor, and in this array we are going to place just one item that would be the prefab that we have just created. Okay, first of all, this level controller, we need to add the script level controller. Okay, so now we can proceed to drag the prefab into the array of levels that are in the game controller. Next, what we are going to do is to move the code logic from game controller to level controller related to anything related with the level. Okay, just let's start by moving the public member variables, the array of enemies and the array of NPCs from the game controller to the level controller, and then move all the logic related with them. So in our codes we are going to take both enemy and NPCs, and we are going to move them to the level controller script. Now for all the errors that you are going to find, you are going to move all the methods and functions that depend directly with NPCs and enemies, you are going to move them from GameController to the level controller. Okay, so you are going to and now you have to make sure that everything that was called into the game controller that made reference both to the enemies and NPCs is now calling to the level controller. Okay, so for example, these two methods we are going to remove them, and anything that is calling to these two methods we are going to replace it by the call to the level controller. Just check the errors that you are getting in the debug console. Okay, so this is going to point to the level controller, also this one, and in the level controller to the player we are going to make reference to the player just by accessing to the Singleton game controller to the reference to my player. Just keep fixing the errors until there is none, and make sure that any code that you have moved from one place to another is properly replaced. For example, in the initialize logic elements we move the logic, okay, of initialization from here to the level controller, okay, and we need to initialize, so we set this one to public, also the stop logic elements to public, so we can make reference to the initialize logic elements on the game controller with level controller instance initialize logic elements, and in the stop logic elements exactly the same. The goal of doing this step is just moving everything related to the level to the level controller, so we still have this exactly the same behavior, but we are reorganizing our code in order to be able to grow in a more clean and stable way. Next, back on the Unity editor, we access to the level prefab, okay, and on the level prefab we are going to instantiate to fill both arrays, the array of enemies and the array of NPCs with what we have in the level. Okay, so open the level, edit the prefab, and change, if you are in 2D, change to 3D, and you are going to initialize the level enemies with the number of enemies that you have. In this case we have 3 enemies, and for the NPCs exactly the same, we have 3 NPCs, so we set them on the array. Okay, so we have our prefab with the enemies and the NPCs initialized in that array. Now back to the code, we are going to instantiate the level when the game changes to the state load game. So let's go to the code, and in the exact moment that we are transitioning from main menu to load game, in the moment that we are on the load game, we are going to instantiate this level. Okay, so we are going to instantiate levels. We are going to instantiate the only level we currently have, that it's in the position 0. Okay, and before we run the game, just make sure that we are disabling the gravity of the player, because the player physics are activated just from the start, and we can fall in the main menu state, because in the main menu state we no longer have the floor to stop the player from falling. So what we are going to do is just on the start of the game controller, we are going to set that the user gravity is false. Okay, and we are going to activate the user gravity once the player transitions to the state of game running. By doing this, we ensure that the player won't fall as soon as we start the whole application. Now we can proceed to run, and if everything goes as expected, we should have exactly the same behavior as before, except that the level is not being instantiated at the beginning, but we have an error right here. Okay, if we keep track of the error, this line, the line 44, so this is null, and we are going to take this opportunity to see another critical method of that provides the mono behavior class, that it's the method awake. The method awake is being called before the method start, and the method awake is usually used to initialize the members of a class. Okay, so we can use the awake method because right now what is happening is that in the game controller state, when the game controller Unity calls the start method, it is changing the state, and the actions that are being performed in the change state include to play a certain sound. Okay, when we go to play that certain sound, we access to the audio source channel, but this audio source channel was being initialized on start, and maybe this start method has not been yet called. So to ensure that these references are already there when other start methods are being called, we can use the awake functionality. Okay, so now if we go back to our Unity project and proceed to play, okay, now we can hear the sounds, and we will be able to reproduce exactly the same behavior as before. Okay, as you have seen, we are at exactly the same state as before, but with the advantage that we have applied a new level of organization to our project with the structure of the level controller that will allow us to create multiple levels in a more clean and organized way. Before continuing, we are going to do a couple of changes. The first one, we are going to add to the level controller script this method. Okay, and what this method is going to do is just to release all the resources, okay, that the level controller has allocated in memory. Okay, so we have a way to ensure that everything is cleaned perfectly in order to start a new level with everything previously executed having been removed. And this method we are going to call the destroy just before the initialization of the new level. Okay, so we are going to call the destroyed just right here. We check if we have the instance of the level controller in the scene, and if we do, we just clean it. Okay, so the next step is that it's time to create different levels. Okay, so let's go back to the Unity editor, and here what the first thing that we are going to do is we are going to rename the level to level 0. Okay, so it's easier to keep track of the levels. And now we are going to drag the level multiple times, okay, on the scene to create different levels. Okay, let's create it at least 2 times. Okay, and for each one of the levels that we have placed on the scene, we are going to unpack it. Unpack means that we are breaking the connection with the prefab. Okay, so that way any change that we'll do on this game object will be in a separate different object, not linked with this prefab, because what we want is to create just a new level. Okay, so and we are going to rename them as level 1 and level 2. Okay, okay, once we have these 2 levels, for the moment we are going to drag them to the prefabs level folder just to create the prefab, and we can remove them from the scene. Okay, next thing that we are going to do is in the game controller we are going to add to the array 2 more items. Okay, and we are going to initialize the additional 2 more entries to the new levels that we have just created. Okay, so now it's time for customize each level. Okay, so what I ask you to do is that for each level you are going to at least customize the floor. Okay, you are going to apply a different texture, so it's easier to differentiate. Also, you have to change some of the static game objects, and even enable or disable some of the existing game objects that we have already here. Okay, so feel free to customize each one of the levels, so you are able to differentiate them when you transition between them. Okay, and yeah, go ahead and just do it. And we'll see. And also, if you create new enemies or remove them from the scene, just make sure to update. In the case that you are adding enemies, just increase the number of items that the array contains to set up the enemies, or if you are removing the enemies, just set less items in order to just reference the elements that are on the scene. So go ahead and please customize these 2 new levels. Okay, so once you have fully customized both three levels, so you can differentiate between each of them once we load them. Okay, we should be good to go. So now that we have our three levels, it's time to prepare the code to be able to change between them. In order to do that, we are going to create a public member variable in GameController that would be an integer that will keep the current level where we are. Okay, so let's go to the codes, and we are going to create this public member variable current level. Okay, and we will use this variable to load the right level. Okay, so think about where you have to use this variable to load just the current level. So think for a second for it. And the solution is just in the moment that we are instantiating the level, we just instantiate the current level. Okay, now you have to find where do we have to increment this variable. Just think about it for a second. Okay, and the solution is that when exactly the moment we change the state, we should increment the variable. Okay, since we have only 3 levels, in order to avoid to have a problem when we go beyond the 3rd level, in case the current level is beyond 2, we are going to set the variable back to 0, just to control that the game doesn't break. Okay, so there is only one thing left to do in order to load a new level. Okay, again, think for a second about it. Okay, and the solution is that when we are pressing the next button, we are right now well, going to the main menu. Okay, so here we need to go to the load game again, because when we press the next button, both on win and on lose, we need to reload. Well, in the case of winning, of course the current level is incremented, and we go to the transition to the load game state, where we destroy any previous level and load the current level. Okay, and in the case of the lose state, when we press the next button or the replay button, we are just loading again the game. We are just changing the game state to load game, and since we are not incrementing the current level variable, we are just instantiating the same level as before. One last thing that we need to check to ensure that everything is going to work as we expect, we go to both to the win screen, okay, and we check that the go to next level button is going to activate that transition. Okay, so right now, because right now we don't have any callback in the on-click properties of the button to go to the next level, so we are going to create a public method that will change the press to next button. So we have this variable that I think that it's wrong, the naming convention right now, so we are going to change it. Okay, so we are going to rename it, so has press go to the next level. Okay, this is a more appropriate name for what we need to do. And you can see here the public method that calls that changes this variable to true in order for both conditions to transition to the loads here and here. Okay, so this method that will set that boolean variable, we also are going to rename it. Okay, we are going to rename it press go to next level. Okay, and now back to the Unity project. When the user clicks on the button, we are going to call the callback go to the next level of the game controller. Okay, so press go to the next level. Okay, we have for the win, and we need to do it also for the lose. Okay, so for this button again, we are going to make that this also go to press to the next level. But in this particular case, what it's going to happen is that the current level is not going to be increased, and so the same level is going to be reloaded. Okay, so now we can proceed to run the application. Okay, and if everything goes as expected. Okay, in order for the music not to be in the way, we are going to do one change. Okay, so in the level controller, in the sounds controller, we are going to create a public member variable. Okay, public boolean enable sound. Okay, and we will place this one to false. Okay, and what we are going to do is just write in the moment that when I am going to play the sound, if this variable is false, then we don't play anything. And we do exactly the same for the effects. In the exact moment that we are using the audio source, the channel, to play the sound, just in that moment, if the variable is set to false, we don't play the sound. By this way, I would be able to explain things because with the sound it's going to be difficult to do it. Okay, so going back to the game now, if everything goes as expected, we should be able to transition from one level to another. So let's go into to do it. Okay, so let's kill all the enemies. Okay, we are on the win state. Okay, so if we press the next button, okay, we have loaded the next state, but we didn't disable the win screen. So we are going to do that. Okay, so we are going to disable the screens on the load states. So disable all the screens. We can do it just right here when we are transitioning to the load game state. So let's try it again. Play, kill the enemies. Okay, and let's try again. Okay, we are on the next level. The logic of the enemies is being triggered. They are shooting at us. Okay, that's good. We are able to collect the coins. That's also good. And we should also be able to receive some damage if we collide with the spikes. Okay, also good. And let's check the portals life to 70. That's also good. And the NPCs, they are also working. Okay, let's kill the remaining two enemies to transition to the other state. And okay, we are on the final level. Okay, we can make that this enemy is killed by the spikes. Luckily, no, he still needs some spikes maybe. Let's see if we can manage to make it. Okay, let's see. No, not enough. Not enough. Let's see. Not enough yet. Okay. Okay, that's cool. Okay, we have killed both enemies using the spikes. Okay, our level controller system is properly working. Okay. So to end the part of the level controller singleton, we are going to do a couple of exercises. Okay, so the first exercise, the first optional exercise I propose, is to reset the position of the player every time we load a game. So it starts from an initial position always. And the second exercise is destroy any existing bullets every time we load we change to the load game state. Okay, so feel free to do these exercises. Okay, so the exercises we have made are these ones. For the player to reset on the initial position every time we load a new level, we have created a private member variable, initial position. We set for just the first time the initial position to the current position, and we create a method that allow us to reset the current position to the initial position. Next thing that we have done is that when we are loading the game, in that transition of state, we are resetting the player position. Okay, and the second exercise was to destroy all the bullets, and I have used the moment that I release all the resources of the level just to look for all the existing bullets with game object find objects of type that will return all the existing bullets that are on the scene, and I go through all the existing bullets, destroying them. Okay, so if everything works as expected, we can check the whole thing with just the position thing. So we proceed to kill all the enemies, so we trigger the next level, so we can see that we are restarting the position in the initial position. So now when I press, I would be centered again. Okay, so I am centered again, and well, I am able to play the level, and if I happen to die, then I would be resetting also in the initial position. So if I replay level, I start again in the initial position. Okay, so the resetting position for the player is working fine, and the bullets are also being destroyed when we are transitioning off level. If you can check the bullets on the scene, let's kill all the enemies. It's only one enemy, so let's create as many bullets as we can, and we can trigger and when we press next level, all the bullets are gone because we have destroyed all of them. Okay, so we have finished with the level controller Singleton. This is the last Singleton pattern that we are going to do to finish with the introduction of the Singleton patterns, and it will be the Singleton pattern called screen controller. Okay, so we are going to keep going with the reorganization of the project in order to grow cleaner and more stable. Now we are going to create another Singleton pattern called screen controller. This controller will handle the creation of the screens. Why do we have to do it this way? Because when you try to create a project that needs to grow, it's necessary to keep the scene as clean, as minimal as possible. You have to understand that when you are working in a team and everybody is working in the same scene, the work becomes a nightmare because people would be overwriting with their changes the work of the others. Okay, so that's the reason why it's necessary to have a really small scene and to have all the elements as prefabs, so the people in the team can work on individual prefabs without colliding with other colleagues. Okay, so what we are going to do first is to create the script screen controllers in our folder controller. So let's go to the code and we can create here the script screen controller. Okay, the first step, just add the accessor. So anywhere from the code we can access to this Singleton and replace the reference to the script so it makes reference to the screen controller. Okay, so we have our accessor for the Singleton, and now we go to the scene and we create the empty game object screen controller. Okay, screen controller, and we added the script screen controller. Now we are going to convert to prefabs all the screens that are in the scene. So let's create a folder in the asset game resources prefabs with the name screens. Okay, so here we are going to create a new folder called screens. Okay, and what we are going to do inside this folder is for all our screens except the game HUD for the moment, but for all our screens we are going to convert them to prefabs. Okay, so let's first enable them, and we are going to convert all the screens to prefabs. Okay, and what we are going to do next is to remove them from the scene. Okay, and the next step that we are going to do is going to be really similar to the one we did with the sounds. Okay, in the case of the sounds, we created an array that we filled with all the audio clips that the game was going to use, and we are going to do exactly the same for the screen controller. We are going to create an array with all the screens that we are going to use. Okay, so let's go to the code, and we are going to create an array of game objects that will contain all the screens. Okay, back to the Unity editor, we are going to fill this array with all the existing screens, so 5. Okay, and we are going to initialize this array with all these screens. It doesn't matter the order. Okay, once we have initialized this array, we can go back to the code, back to the GameController script, and in this script we are going to remove all the reference to the screen. Okay, so all these reference, the main menu, the load game, the win game, lose game, and post game screens, all of this will be removed. Okay, And what you are going to do is just for the moment comment all these lines, okay, because later on we are going to fix it. Okay, just save and check in the Unity editor that there are no compiler errors. Okay, so we don't have compiler errors. And the next thing that we are going to do, in a similar way as we did with the sounds controller, we are going to create a public method that will be called create a screen. This method will have two parameters. It will have the parameter string as the name of the string. As I said, it's really similar to the sounds controller. We are also going to look by the name of the screen. Okay, and the second parameter will be called destroy previous screen. Okay, first of all, we are going to create in this method. We are going to create the screen, going through all the elements and looking by its name. Once we found the prefab we need to instantiate, we instantiate it. So it's time to go back to the code and implement this method create a screen in the screen controller. Okay, so we are going to create a method and just do it by yourself and come back when you get it done. Okay, and the method should look similar to this. So we have created a public void with the parameters name screen and destroy previous screen, and just for the moment we are going through all the elements looking for the screen name that is in this case just the name of each one of these prefabs. Okay, and when we found the screen we are looking for, we instantiate it. Okay, so now it's time to call our Singleton screen controller. Find out where you should call it to create the screen main menu. And once you have found the place and you are calling it, run it and think about why it doesn't work. Okay. So you should have a code similar to this. In the moment that we are activating the screen, the main menu screen, we are calling the Singleton. We are calling the Singleton with the name of the screen we want to create, and this parameter that is still not used. Okay, and if you have proceed to play the project, you would have noticed that it doesn't happen anything, because all the connections that were in the scene related to this button triggering a method on the game controller are no longer here. We have to implement it in another way. Okay, another way that it will be cleaner and it will be easier to do better progress with this new way. So in order to restore the behavior of the buttons and the other elements, we have to create classes for each one of the screens that we have created as a prefabs. Okay, so we will start with the main menu screen, and what we are going to do, going back to the code, we are going to create a new folder in the scripts folder. So here, right here, we are going to create a new folder that we will call screens, and inside this folder we are going to create the script screen menu main. Okay, so inside this folder we are going to create a screen menu main. And we are going to attach this script to the main menu screen prefab. Okay, so we are going to attach the screen menu main. Okay, now going back to Visual Studio, what we are going to do is that here we are going to restore the connections, the functionality that this screen had. Okay, first of all, we will start by restoring the button interaction, and to restore that, on the start method we will access to the child by the name play game. Okay, what we are interested is that for the main menu prefab to get the this child that is the one that contains the component button. Okay, so we are going to do this together. Okay, so in order to access to the childs, remember that you have the functionality find. Okay, with then you can use a string to look for the name of the child. In this case is play game, and we will be getting exactly the button right here. Okay, and now of this button we can retrieve the component button. Okay, we import the necessary libraries, that is Unity Engine UI, and now we can access to the properties of the button. And the button has the event on click, and the event on click we can add a listener. Okay, just exactly that as we did before when we were, just let me comment this, just like we did before that we were creating on click, we can do it exactly the same but by code. Okay, we can remove this one because it's no longer operative. Okay, so back to the code. What we are doing here is exactly the same what we were doing, just by adding to the on click. We are adding a listener. Okay, and when the user press on that button, this would be triggered, and this would call a function that we will define right here. We will call this function press play button. Okay, we will create this method. Remember that you have the option to autocomplete just by pressing Ctrl dot, and the autocomplete function will help you out to create the method. Okay, so this is the method that will be called when the user press on the play game button. Now think about what method do you need to call in the game controller in order to transition from the main menu state to the load game state. So think about it and do it. And the solution should look similar to this. Okay, so we are listening when the on-click event for the button has been triggered to call this method, and this method will call the game controller singleton, and we will call the method that we already were using before when we were using just in the inspector the property on click to define the method. Instead of using the inspector, we are using the code. Okay, so the flow would be like this. The button has been pressed, this event has been triggered, and this callback is being called, and this callback will call the play clicked method that at the same time will trigger this variable that will report us that we have the permission to transition from the main menu state to the load game state. So if we proceed to run, we should at least transition from the main menu state to the load game state. Okay, so let's try to do it. Let's see what happens. So let's ensure that we have the debug log enabled in order to see what's going on. So we are going to press the play game. Okay, so the load has been triggered. Also, we are right now on the state game running. So the transition to the game running state has been performed. We are on the game running state, but you can see that we still have the main menu screen on the screen. Okay, so let's go into to fix that. In order to fix that, we are interested to keep track of all the previously created instantiated screens in order to destroy any previous screen if we need to. So what we are going to do to keep the track of these screens, we are going to create a private member variable in the screen controller script that would be a list of the previously created screens. Okay, so you can just copy paste this code into the screen controller. Okay, and when you instantiate a new screen, you should add the new reference to that list. Okay, and the way to do it is just like this. You get the reference right here and you just add it to the list. So you can also copy paste this one. Okay, so right now, aside from creating the screen, we are keeping track of the screens created. So now what we are going to do is to implement the functionality related to the destruction of the screens, thanks to the parameter destroy previous screen. When this parameter is true, we are going to destroy any previous screen that has been stored in this list. So please implement that. Check when this variable is true to destroy any previous screen that was stored in this list. So go ahead and do it. Okay, and the code should look similar to this. We are checking the parameter, the Boolean parameter, and if this is true, we are going through all the screens that are stored in that list, and we destroy each one of them. Finally, we clear the list of all the elements, and then we proceed to create the next screen. Okay, so now what you are going to think about is, okay, so we are going to find out where to call the next screen, the loading screen. Okay, so find the place where to call the create screen for the loading screen, and just check that the previous screen, the main menu screen, is destroyed. Okay, and the result should look like this. In the activation screen load game, we are creating the screen with the name of the prefab that is the load screen, and with the parameter true, so the previous screens are destroyed. So the behavior we should get right now is this one. We press play, the loading and the main menu screen has disappeared, but the loading screen is still there. Okay, let's go into fix that. In order to fix that, what we should do is we are going to implement a new method in the screen controller that we will call destroy screens. And what would do this method is just to go through all the screens and destroy them. So we can just use what we have already done and define it like this. Okay, and now what we are going to do is just in the exact moment that we are transitioning to the game running state, we are going to destroy the screens, all the screens. So we are going to call the screen controller and we are going to tell it, please destroy all the screens. Okay, but there is a thing right here that we need to change, because we are just calling again the screen, the activation screen load game, and we are calling it again. So we will create again the whole thing. So in order to fix this thing, what you are going to do just right now, you are going to just remove all the activate from all the creation of the screens, that is for the activation screen menu main, activation screen load game, the screen win game, screen lose game, and the post game. Let me find the post game screen. Activation screen post game, it's here and from here. Okay, so we have removed this parameter, and in all the cases that the activation was false, we are just going to remove that cases because are no longer necessary. Okay, the cases that were true, yes, we need to create that screen, but in the cases that were false, we don't need to create it anymore. Okay, so what we are going to do in the cases that the screen is false, we don't need it anymore. Also not here, but in the case that it's true, we need it because we need to create that screen. Okay, now we can proceed to save and test the project, and now you should get into the state game running without anything in the way. Okay, play the game, loading, and you are back to the game. The next thing that we are going to restore, if you remember, we were using the language controller just to set some language on text fields. So we are going to restore that in our script screen main menu. Okay, so go ahead and first of all just restore only retrieving the text fields, getting the component and setting the text with the right language. Okay, go ahead and do it. Okay, and the solution should look similar to this. What we have just done has been to retrieve the right child both for the title and inside the button of switching the language, retrieving the text component and setting the text with the right information retrieved from the language controller. Okay, if we proceed to play, now we are getting the right text both in the title and in the button. The button is not yet working, so this is the next thing that we are going to do. So go ahead and do it, and as a reference, think about this, what we have done here. Okay. and the solution should look similar to this. What we have done here is just as we did with the play game button, we are retrieving the language switcher button, retrieving the component button, and listening for the event on click. We have created this callback function that the only thing it does is switching between the two available languages and refreshing the text. So if we go back to the Unity editor and press play, we should have restored the behavior of switching the languages. Okay, so the next thing that we are going to do exactly the same for the rest of the screens. For the screen, the win, for the lose screen, and for the pause screen. You are going to create scripts for each one of them, and in each script you are going to initialize both the buttons and the text in order to restore the behavior we had before. Okay, so first take as a reference the screen main menu and try to start by restoring first the button interaction. After the button interaction, you can try to restore the text with the language controller. So go ahead and do it. Okay, and the result should look similar to this. What we have done is exactly the same that as we did with the screen main menu. We have started with the screen win. First of all, just by getting the text component and setting the right value using the language controller Singleton to get the screen win text. Next, we have retrieved the references to the buttons, okay, for the go to next level button, and for the go to main button. And we are listening to the events on click, and we have implemented a callback function that will be called when these buttons are clicked. And what these callback functions do is just to call the previous methods that trigger the conditions that will allow us to transition to the right states. Okay, we have done this for the screen win, and also we did it for the screen lose that shares almost exactly the same. Okay, and finally we have done it also for the screen pause. In the screen pause right now, since we are not using any specific text for the pause screen, we are not just setting any text right here. As an exercise, if you want, just create a new entry and consider to use it. For example, let's do it now. And the pause screen has the component text. Okay, so what we can do, okay, we have covered the case for the text. For this text, we have created a new entry in our language text files, and in the screen pause we are getting the reference to the text child, getting the text mesh pro, and setting the text with the translation we are looking for. Okay, finally what we have done has been just to, in the moment that we need to create the screen win, the screen lose, and the screen pause, in that specific moment we are just creating the screen and destroying any previous screen. If everything goes as expected and proceed to play, we are going to test all the cases. Okay, so we are now on the game running state, and let's check the pause screen. Okay, the enemy is going towards us. We press pause. Okay, we are getting the right text gaming pause, the one that we have defined right in the language text file, and we are using in the initialization of the script screen pause. Okay, so everything is in order, and the button resume should resume the game, so we can continue. Okay, the next screen we can test is the screen win, so let's kill all the enemies. Okay, and the screen win, at least the text, you are great, you won, we are getting the right text. Okay, and let's check the next level button. If we press next, okay, we have transition to the next level, and everything seems to be working fine. We can collect the coins, the enemies are interacting with us. Okay, and I am losing life. With the spikes, I am losing life. Okay, let's test the final screen. That would be the screen lose. Okay, let's lose life now. And in order to replay the same level, let's place replay level, and we are back to the center of the initial position, and we can start this second level again. Okay, with this last test we have concluded both the screen controller Singleton and also the whole lesson about Singleton patterns. In the case of this last part, we created a Singleton called the screen controller that allow us to convert all the screens to prefabs. Why we did that? Why we moved the screens from the scene to prefabs? Because now you can work in parallel with your colleagues. When you are in a team, you have to make everything possible so all the team members can work in parallel. By doing what we have done with the screens, with the level controller, with converting using prefabs, you make easier the possibility to work in a team. Okay, because now any artist or programmer can work in each individual prefab without overriding the changes of the other people. Also, this applies to the level controller with all its levels. And as I said, if you are going to be a team leader, the goal you must have always in mind is that you have to do everything possible in your hand to make that everybody is productive and they don't collide with each other.